Hi, welcome to Learning Monkey. I am Vikram. In this class, we will try to understand count to infinity problem in distance vector routing. In our previous class, we have discussed about routing loops. There we have discussed that the routing loops that are generated within the network are going to create a problem called count to infinity. So that we will try to understand in this class. If you haven't watched our previous video, please watch that video, because without understanding what we have discussed in our previous video, so this example is totally based upon the previous video. So without watching that, you may not be able to understand what we are going to discuss in this class. And every video in our channel is going to be part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. The link for the playlist is provided in the description below. Now, count to infinity problem. So what this count to infinity problem is, so this is how the routing table has been updated. So after D got connected, so after D got connected, this is how the routing table has been updated. Until here there is no problem, so the system will get stabilized. So with this, what we are going to understand is, for C to transmit the data to D, it has a distance of 1. In the same way, for B to transmit the data to D, it has to go through C, and the distance is 2. That is what this 2 is representing. Similarly, if A wants to transmit the data to D, it has a distance of 3. Okay, so now for example, assume that this link has been broken. If the link has been broken, so who will know? The C will, as the C is directly connected to D, the C will know that the connection between C and D has been broken. Now with this broken link, the C will update that it is not reachable. As the C is not reachable, it will update its distance value to infinite, and these values will remain the same, but this value has been updated. Now after a particular period of time, again the distance vectors will get exchanged between the directly connected nodes. Now what happens is, this exchange has happened. So these values has been exchanged between the immediately directly connected nodes. So with this what happens is, now the routing tables, with this knowledge of these values, now the routing tables will get updated. So how they will get updated? So how they will get updated is, so with this 2 transmitting to C, so what the C will think that, so for me to transmit, as its value is infinite, for me to transmit the data to D, for C to transmit the data to D, it has to transmit it to B. So B is responsible to transmit to D with a distance of 2. Okay, so with that, so the C will get updated to 3. So how this value has been taken? So what happened here is, for C to transmit the data to D, so this 2 states that B can reach D with a distance of 2. So in order for C to transmit the data, it has to transmit it to B, and B is taking the responsibility to transmit the data to D in a distance of 2. So for the transmission of data from C to B, it is taking an amount of 1. So 2 plus 1. So from B to D it is 2, and from C to B it is 1. So the total of 3 units of distance. So now the C will get update its value to 3. Similarly, what is the knowledge that it is going to get? Infinite it is going to get. C, what is the knowledge that B is going to get? It is going to get another information, that 3. This 3 will also get transmitted to B. Now what the B will understand is, it will always, so once again I am telling this point, so it is not worried about, so any node is not worried about its own value. Even though it is smaller, it is not worried about its own value. So it will consider the values from the neighbors, the data that is being transmitted from neighbors, because the neighbors only know what's happening in the network, if there is a failure or not. Okay, so now what happened is, 3 will get transmitted to B from A to B. So now what it will understand is, for him to transmit the data to D, it has to transmit its value to A, and A will transmit it to D with a distance of 3. So from B to A, how much distance? It is 1. 1 plus A to D, it is 3. 1 plus 3 is 4. So now it will get updated its value. This value will get updated to 4. This point is very important to understand. Please try to understand that point. Because this value is smaller, why we are updating it to 4? But the B has to believe in its neighbors. So based upon the neighbor values, so from those values, whatever the minimum value that we are going to get, that will get considered. We have seen that formula also. So for in the process of updating this B value, infinite plus value and 3 plus 1. So what is the smallest one? 4 when compared with infinite. So the 4 will get updated. So please go through our distance vector routing algorithm. There we have clearly explained. Okay. So now what about this 3? This A. A got the information 2. Okay. So with 2, so what the information is? So in order for A to transmit to D, it can transmit it to the B, and B is capable of transmitting it at a distance of 2. So from A to B it is 1 and B to D it is 2. So it will get updated to 3. So it remains the same. Okay, it will get updated to 3. Again the exchange happened. After some period of time, again the exchange happened. So these values were periodically they will get updated. Okay, so again the values has been updated. So now what happens? So here it got 4, for this 2 it got 4, and from C to B it has to transmit, so C to B it is 1 and B is capable of transmitting it to D at a distance of 4. So 4 plus 1 it is 5. So how we got that 5? Again I am explaining it. This 4 has been transmitted to C. This 4 value of B has been transmitted because they are immediately connected. 4 has been transmitted. Now for C to transmit to B, it is going to take a distance of 1. 4 plus 1, 5. So this one will be the same. Now it has transmitted 3. And this also has transmitted 3. So both are transmitting 3. For it to transmit to D, either it should go to C or to A, as both of them are taking a distance of 4. So from B to A it is 1 and A to D it is 3. So total is 4. B to C it is 1 and from C to D also it is C to D it is 3. 3 plus 1 is 4. So it can go either way. So this one will remain the same. It can go either through C or through A, but the distance is same. As the distance is same, so it can go either through A or through C. So this one remains the same. Now what about this? So it has transmitted 4. So what is the update that it is got? It got 4. Now for this A to transmit to D, it has to transmit the data to B, and B will take it in a distance of 4. With the latest update, with the latest transfer of 4 from B to A, it will get updated to 5. So the point is, even though it is smaller, why it is updating to 5? That is very important, as we have discussed already. Okay, so now again the transfer happens. So this is what we call it as count to infinity. So and this count to infinity is here. These values are incrementing one update after the another update. So the values are incrementing at each and every update. See here, it is 3 initially, now it has become 5. As we go on, these values will get updated to infinity. So these values will continuously get incremented. So let's try to understand that. Okay, again the exchange has been done. So for this it got 4, and for 4 it has to, okay, let's take the diagram. Yeah, it sent 4 and from here to here it is 4, from here to here it is 4, and for it to transfer C to B it is 1, so it remains the same, 5, and here it has transmitted 5. See here, it transmitted 5. So 5 for this B to transmit the data to D, it takes 5 units of distance if it transmit through C, and from B to C it is taking 1 unit of time. So it is 5 plus 1, which is 6. This one again becomes 6. Similarly, if you take this will remain the same because it got 4. 4 plus 1 is 5. I am going a little bit faster. Okay. So again the update has been done. Okay, so now what happens? 6 plus 6 has been transmitted to C. 6 plus 1. So from for C to transmit the data to D, it has to transmit B. It has to transmit it to B, and B will be responsible for sending it to D in a distance of 6. 6 plus 1, it is 7. So this 7 will get updated, and this 5, sorry, okay, it has transmitted, sorry, 7 is here, and this 6 will be remains the same, and 7 will be updated. So again in the next count, what it will do, this 7 plus 1, it is 8, and these 7 and 7 will remain the same. So hope you got the point of how the incrementing is getting done. If you go on, these values will go on up to infinity. Okay, so that infinity, as we don't know about the infinity, that infinity threshold value is taken by the network. At most it is going to take the value of 16. Okay, so this is what we call it as 16 means that value is the infinity value. So if it reached infinity means there is something wrong in the network. Okay, so this problem is what we call it as count to infinity problem, which occurs in distance vector routing algorithm because of that routing loops that we have seen in our previous class. Hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this class, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol, and please share this video with your friends so that they will also get benefited. Thanks for watching.